Happy Tuesday evening, algebra students. Today, or tonight rather, we're going to look at some function notation. Function notation is kind of what we've been talking about by writing a function of x, f of x. The only difference is now I'm going to open it up where you can choose any letter. And each letter is going to stand for a certain rule. So for example, in this problem right here, we have the rule 2x plus 3. And that is going to be f of x. Okay, then they give us the domain up at the top, meaning the points they want us to plug into x. So we have f of -1, f of 0, and f of 1. And then you plug it in and solve, and that gives you your range. This is kind of like what we've been practicing. We're looking at distinct points inside of a function now. Okay, so let's try a few together, and then I'm going to let you off on your own. So, it says for numbers 1 through 10, find the range values, which are the y's, of each function for the given domain values. In other words, plug in the points they give you. So, first we're going to start with f of x, and you'll see that here we are given the function f of x equals 6x minus 1. So for each of these points, 0, 2, and 4, we're going to plug in to x those values. So we have f of 0, which is 6 times 0, which is 0, minus 1 would give you -1. Then we're going to plug in 2 for f of 2. 6 times 2 is 12, minus 1 is 11. And now we're going to plug in 4. f of 4 equals 6 times 4, which is 24, minus 1 makes 23. So our range, and bear with me, I'm going to do my best to make these little, oh, that one came out pretty nice. We have -1, 11, and 23. You'll notice that I did, in fact, put my range in the same order that my domain points were in. Okay, let's try another one. This time, we have g of x. G of x is the same as f of x, except we changed the letters. It doesn't actually change anything if you change that first letter. It just means that it's different from f of x, which if you look, this function is different from this function. And this time, I also put in an exponent. Shouldn't be too hard. The domain here is -2, 0, and 4. So we're going to do g of -2, and we're going to plug in -2 squared minus 3. Now when the negative is inside the parentheses, like it is here, that means that we have -2 times -2, which makes positive 4. 4 minus 3 is 1. Coming to the middle, we have 0 squared because we're plugging in 0. 0 squared is 0 minus 3 is -3. And here we're going to plug in 4. Our x is 4, so 4 squared is 16 minus 3 is 13. So our range is those points. 1, -3, and 13. I'm going to let you do 3 and 4 on your own, but I do want to talk about one more type of problem on this page. You'll see that this is just repeatedly asking you to do the same thing. The only difference is they're changing these letters. Not that hard, you're just doing the exact same process. And I'm going to go all the way up through R, but I'm still going to do exactly the same thing. I'm going to plug in my domain values into my function and solve for whatever the y is. That's the range. I do, however, want to look at a few of these. These are a little more tricky, only because I'm asking you to do several things at once. Okay, so we're going to look at right here where we have a addition of two functional values. So for number 18, I have f of negative 1, which f is 3x minus 1. So I'm going to go ahead and plug in negative 1 to my f value here. So I have 3 times negative 1, which is negative 1. Negative 3 minus 1, which is negative 4. And then I'm also going to plug in 4. 3 times 4 is 12, minus 1 is 11. So I have negative 4 plus 11, or 11 minus 4, which is 7. Looks pretty complex, but it's actually really easy. I would like you to hold off on 24, 25, and 26 until we get into class. Please do not attempt to do those. We will do them together in class. I hope that you have a great night, and I'll see you tomorrow.